Today we're going to learn about compound inequalities. So compound inequalities is when something, more than one thing is happening. That's where we get the name compound for. So we're going to look first at the ones with have and statements. So we have to look, and they can be written a couple of different ways. If they have the word and, obviously it's there. What we have to know about this, anytime we see the word and, we have to know that it has to meet both rules. So this must meet both rules. So in our first problem example here, it says x is greater than or equal to -2 and x is less than 5. So I have a number line here, and the best way to think about it, you need to have these two numbers on there, and I like to put another starting point. Sometimes you don't have to, so we'll talk about that. You need to definitely at least have 5 and -2. I'm going to put a 0 just kind of for a placeholder. I know that -2 would be somewhere down here, and 5 would be somewhere up here. Now, we can start with what type of circles we're going to have. So we know that a greater than or equal sign has to be a closed circle. Think about it's including that number. Whereas if we don't have the equal sign under it, it's an open circle. So this would be an open circle. So we're going to put an open circle on 5 and a closed circle on -2. So we've plotted our 2 points. Now we're going to kind of do some little guidelines first before we shade in our line. So let's start here. X has to be greater than -2. So numbers that are bigger than -2 are going to be from -2, and they're going to go this way. So it's going to go forever and infinity. But this also has to match an and statement. It also, whatever number, has to also be less than 5. So less than 5, not including 5, would be going this direction. Where they overlap, in this area that they overlap, is where our solutions are. So when we shade in our line, we're shading it in this section. So this means that x can be bigger than -2, but we get to 5, it has to be less than 5. So it can't be 6. So you got to see if it works. So when you look at your line that you've graphed, this is a visual representation of your solution. So you need to make sure that it actually matches your solution. So if I pick 6 fits the greater than or equal to -2, but it does not also fit x is less than 5. And remember, this has to meet both rules. All right, let's try B. So x has to be greater than or equal to -5, and x has to be less than or equal to 7. So we're going to go ahead and make sure that our numbers that we're talking about are on the number line, kind of spaced apart, kind of where they would be. Didn't have to be perfect. This is just a visual representation, again, of our solution. So we're going to start with our closed circle here, and we're going to have a closed circle here. And then we can do kind of our little guidelines and see. So x has to be greater than -5, so that means it would be going this way. But it also has to be, at the same time, less than or equal to 7. So less than or equal to 7 is this way. So where they overlap is our answer. So these are in the middle. Most of the time, about 90% of the time, when we have an and statement, they will be in the middle, but they're always rule breakers. So let's move on to a 1 star. These are still using and statements. However, you don't see the word and anymore. So what this is really saying is that n is greater than or equal to -6, and n is less than 2. So it's still an and statement, but it doesn't use the word and. So they're kind of squished together. We know those are and statements. So again, we're going to start with a -6 and a +2. We're going to have a closed circle here because it's included, and an open circle here. So now we can look at each individual piece. We know that n has to be greater than -6. So greater than, and you can always read from the variable over. This is open, it's greater. Greater than -6 is going to go this way. N has to be less than 2 is going to go this way. So again, we're going to fill in our line where those two pieces overlap. Now let's go to a 4 star. Again, this is an and statement. We have 4 is greater than x, or we can say x is less than 4, and x is less than 10. So we're going to have our 4, and we're going to have our 10. We're going to have open circles on both, And now we're going to kind of do our little graph. Remember, if we need to set this up individually, this is saying x is less than 4 and x is less than 10. So let's do our guidelines. So x is less than 4 goes this way. X is less than 10 goes this way. Notice where they overlap is just in this area right here. We cannot cover in the area 5, 6, 7, 8, 9, and so forth because that does not meet both rules. We have to have both rules being met because it's an and statement. So we only shade in this area to the left of 4. All right, so we got a little squiggly. We're going to change our train of thought and we're going to talk about or statements. So these are or statements, and or statements have a little bit more leeway. They only have to fit one of the rules. Okay, one or the other, doesn't matter. It only has to fit one at a time. It's an or, either or. Now, our graph still must be graphed fully to show our solution. So let's start with this first one. So we're still going to look at -3 and 7. We still do closed dots or open, depending on what type of sign that we have for inequality. And now we're going to do our representation before we do the line. So x has to be less than or equal to -3. That would go this way. And x has to be greater than 7. This would go this way. Well, remember, they don't have to overlap. It can be either or. So we're going to shade in the areas that we represented. So this can go on forever. So we could have a number like -8. It fits one of the rules. That's all it has to fit. It's an or statement. We could have a 100. It fits the rule. If this was an and statement, we could not have this as an and statement because there's no number that would fit both of the rules. So this, if it was an and statement, if we change this or to an and, this would be a no solution. All right, let's look at the next one. X is less than 10 or x is less than 4. So here's our 4 and here's our 10. And they're trying to trick you by writing them opposite, but don't let it fool you. Still open circles. You can go ahead and put your open circles there. It says x is less than 10, so we're going to do here. Or x is less than 4. So remember, it doesn't have to be where it's overlapped. We actually can have numbers in here. So we can have 6 because it fits a criteria of x is less than 10. But we also can have numbers here as well. Of course, they fit both in that category. But our things here, and then because we left this open circle, 4 is actually included because 4 is less than 10. So we can actually then close in that circle. So our answers would be any number less than 10 but not equal to 10. All right, we have another squiggly, so we're going to talk about how they're written a little bit more algebraically. So our first example, when we think about it being stuck together, that's an and statement. So the first thing you have to think about is we're talking about and statements. The ors will be written as ors. So that's pretty easy. They always write the or for you. And you have to look at it a little closer. So what this is saying, this is two different statements. It's basically saying -1 and x plus 3 and x plus 3 is less than 5. So it's just two statements that are breaking up there. So we're going to solve them separately. So we want to get x alone. So x is here. So we want to get everything away from it. So we just do it like an equation. We're going to solve it like an equation. So -3. So we end up with -4. And this here. Now, if you like to see how it's written first, saying your variable, you can just flip it around. This is the same thing as x is greater than -4. Sometimes it's easier for our brain to see that. And then we still have our and statement, and now we're going to do this one. So -3, we have x, and we have 2. So now we're going to graph it. So we're going to use our number line. We're going to at least have both of these numbers on here. You don't have to have every number, but you got to have these numbers. So -4 and 2. And now we're going to do our open or closed circles. So we have an open, open, and now let's do our representation. X has got to be bigger than -4, so numbers that are bigger go this way. And it's also got to be less than 2, so numbers less than 2 go this way. And because this is an and statement, we're looking where these overlap here, so here is where we will shade in the middle. All right, so here's another example. I want you to pause the video and try this one out. So for this one, I did them all in one fell swoop. So instead of setting it up as 2 individual problems, I knew I need to get X alone in the middle here. So I went ahead and take +1 to all sides. So that's how I ended up with -2 and 8 and left with 2x in the middle. This came down. Then I know I need to still get x alone, so I divide by the coefficient of 2 on all pieces. So I got -1 is less than x, and x is less than 4. So if you need to think about what you're doing and write it a little differently, you can write x is greater than -1, and x is less than 4. So if you need to write it separately to see it, then I did my line, so we would have a graph as such here below. All right, we're going to go to a 1 star, and I'm going to show you a little bit more of how to do this in one fell swoop. So this is still an and statement, and I know that I want to get my x alone in the middle, so I need to start moving things away from it. This is on each side, I'm doing 2 separate problems all in one. So I'm going to take away 3 here, 3 here, and 3 here. This is now gone. 15 minus 3 gives me 12. I keep my sign. And then 6 minus 3 gives me 3. Now I have to get the x alone, but I have a negative coefficient. I'm going to divide by -3 on all sides. But when I divide by a negative, my inequalities switch directions. So this was greater, and it's going to switch. So 12 divided by -3 gives me a -4, but this has to switch directions. It's very important. -3 divided by -3 is gone. We're just having an x left. And 3 divided by -3 gives me a -1, but I have to switch my inequality direction because I divided by a negative. That's true if you divide or multiply by a negative in inequalities. So now this is my final answer here, and now I've got to graph it to give a representation of my solution. So I have a -4 and a -1. This is a closed circle, and this is an open circle. So if I need to see x is greater than or equal to -4 and x is less than -1, this is what I'm doing. It says the same thing, and these are and statements. I have to meet both criteria. So x is greater than or equal to -4, so that goes in that direction, and x is less than -1, that goes in this direction. So where they overlap is here in the center. All right, let's move on to a more difficult one. This is a 4 star. I want you to pause the video and try this one, see how you do. All right, so when we solve for this one, we see that we get 4 is less than n, and n is greater than or equal to 0. But remember, this is an and statement. So I wrote it over here to the side for you to kind of see what we're doing. I went ahead and put them on the number line, and we're going to go do our little lines to kind of help us. So n has to be greater than 4. So that goes in that direction. And then n has to be greater than or equal to 0. Well, we would have a closed circle here, and it has to be this way. Now, the problem is this is an and statement, so it has to meet both criteria at the same time. If we have a number like right here, a number 1 or 2, 2 is not meeting both criteria. It is not bigger than 0 and also at the same time bigger than 4. So we cannot shade that in, which also means we can't shade in 0 here because 0 has to be greater than or equal to 0. So it's not going to be that and also at the same time be greater than 4. So we actually have to take away our solid circle there, and we can leave the 0 on the line. That's no problem. It doesn't hurt anything for it to be on the number line, but we are actually going to just shade in the area that's greater than 4. 4 is not included, but now it meets both criteria. It's greater than 4, and it's also greater or equal to 0. Has to meet both at the same time. All right, we're going to do another little squiggly, and we're going to move into some more complex or statements. So the first one, we do the same way, solve them as equations, two separate ones, and then plot them, but we're going to think about plotting them with OR. So pause the video, try, and then come back and check. All right, so be careful with this one. When you work the side to the right, when you divide by a negative, remember you have to flip here the inequality sign because you divided by a negative. When we graph, we're greater than 3 or less than negative 2 in that direction. So we can have both of these graphed because it's an OR statement. It's either or. It just has to fit one rule. So we could pick any number like 10, it would fit the rule. Negative 300, it would fit the rule. So it's an OR statement. All right, let's go to a 3-star on an OR. I want you to pause and see if you can do this one. All right, so when you work that, you are going to have to move it more like an equation and think about that inequality sign just being an equals and ignore it until you get down to the end. So when we get to, on the left side, we got 3 is greater than C, or C is less than 3 if you want to rewrite the other way. And then on the other side, we got C is less than 7. Now, remember, this is an OR statement, so it has to fit either or, so one of the rules. So let's go ahead and try to graph. So we have 3 and we have 7. We are going to see open circles, and then we're going to look at each individual one. Now, if you need to see this the other way, as C is less than 3, you can rewrite it. It means the same thing. So C is less than 3, that goes this direction, and C is less than 7, that goes this direction. And because it's an OR statement, we don't have to just shade in where they overlap. That would just be an AND statement. We actually can shade in all of this. And because 3 is included in that, we can make him solid now. He's actually included in our choices because it's an OR statement. We could pick 3 and it would meet the criteria of being less than 7. All right, let's move to our last one. This is a Mac Daddy one. I want you to pause the video, try this one, and then we'll go over procedure. All right, so when you get your answer, you should have W is less than negative 2, or, remember this is an OR statement, W is greater than negative 5. So now let's talk about graphs. So I already have my number line there with my numbers on it, and let's talk about graphing this. So we're going to say W is less than negative 2, so this goes this direction, or W is greater than negative 5. These would be open circles. However, this is an OR statement. So if I pick negative 5, it actually fits the criteria of W is less than negative 2. So I can actually include that. If I pick negative 2, even though it was an open circle before, when I look at W is greater than negative 5, it falls within that category. Notice that it goes both directions. Everything. So we actually can shade in the whole line. This is an all solution problem, our real number solution, or we can do infinity, and we know that any number will work for these to be accurate. All right, let's do our procedure wall. So the thing you have to remember about inequalities, you're going to solve the inequality like an equation. Then you're going to graph it based on the solution, whether it's an AND or OR. And you always want to check and make sure, does my graph match my solution? So if I pick a number randomly that is shaded, does it make it true? Is it following the rule? So you're going to have some practice, take your time, and make sure you go through the procedures correctly.